Alright, in chapter 6 and chapter 7, we made inferences about one population parameter. In chapter 6, we constructed the confidence intervals to make an inference about one population parameter: mean, proportion, standard deviation. In chapter 7, we tested the hypothesis about one population parameter: proportion, mean, standard deviation. In chapter 8, we're going to make inferences about two parameters. We're going to start with proportions, and we'll go on to the mean, and then finish with the standard deviation. The main difference between this chapter and the previous chapters is we're making inferences about two proportions, two parameters, as opposed to just one. So the assumptions in 8.2 are as follows. The proportions are from two independent simple random samples. Independent simple random samples. So that means that the two samples are not paired together. They're completely independent of each other. The second assumption is that the conditions for normal approximations are met. So if you recall back to chapter, I believe it was chapter 5 or 6, we found that in order to use normal distributions to approximate binomial distributions, n times p had to be greater than or equal to 5, and n times q had to be greater than or equal to 5. Alright, so those are the two assumptions for this chapter, this section. So we're going to start with the example on page 441. The example on page 441 uses the chapter problem, racial profiling. It says for the sample data listed in table 8.1, use a 0.05 significance level. So we're going to use a 0.05 significance level to test the claim that the proportion of black drivers, which we're going to use 1 to indicate the black drivers, stopped by the police is greater than the proportion of white drivers, which we've indicated the white drivers are going to be 2. So we turn back to the chapter problem on page 437, and we get the following statistics. There were a sample of 200 drivers, black drivers. Of them, 24 were stopped by the police. There were a sample of 1,400 white drivers. Of those, 147 were stopped by the police. Alright, so here we go. This is our claim. Opposite of that would be P1 equals P2. Alternative hypothesis, null hypothesis. So now we're dealing with two proportions. So instead of one prop z-test, we're going to use two prop z-tests. Pretty much everything else should be the same as what we did in the previous chapters. Stat, test, two prop z-test is right there, number 6. And we're going to enter all the information. X1 is 24, N1 is 200, X2 147, N2 1400, and then we have P1 in our alternative hypothesis. P1 is greater than P2, so we should have greater than highlighted. P1 is greater than P2. Hit calculate. Our test statistic is 0.64. And our p-value is 0.260. We compare our p-value to the significance level. It is not less than the significance level, so we fail to reject the null hypothesis. Our formal conclusion there, since we're failing to reject, is not sufficient evidence to our original claim is the alternative hypothesis, so we write support. the claim that, restate the original claim. The proportion of white drivers being stopped by the police is greater than the proportion of proportion of black drivers is greater than the proportion of white drivers. Alright, and lastly would be the critical value, inverse norm, since this is a normal distribution, and our significance level is 0.05. Since the critical value is in the right tail, we're going to use 1 minus alpha. 1 minus 0.05 is 0.95. We go to our calculator, second vars, and inverse norm 0.95, and hit enter. 1.64 is our critical value. Alright, so again, it's pretty much the same as the previous chapters. Only difference is now we're comparing two population parameters, more specifically proportions in this section. So now we're also going to construct the confidence interval. So if we turn to page 444, we are going to construct the confidence interval estimate of the difference between the two proportions. So as you can see, the example on page 444 is referring to that same chapter problem, the racial profiling problem. And so we're going to be able to use the same statistics. We want to use a 90% confidence level, which is 0.90. To construct the confidence interval, use a sample data given to construct a 90% confidence interval estimate of the difference between the two population proportions. Now, if we go ahead and construct this confidence interval right after we tested the hypothesis, the calculator will automatically transfer all the statistics that we entered. It will automatically transfer that to the confidence interval. So if we hit the confidence interval we're going to be using is the 2 prop z interval. That's how we're going to construct the confidence interval for two population proportions. So stat test 2 prop z interval is what we're looking for. 2 prop z interval, there it is, 2 prop z interval. And as you can see, it's transferred all the statistics that we've entered when we tested the claim, transferred it over to the confidence interval. All we have to do is enter the correct confidence level. The confidence level we're using is 0.90. Hit calculate, and there's our confidence interval. -0.0251, -0.0251, P1, P2, and 0.0551. Alright, so we are 90% confident that the interval from -0.0251 to 0.0551 contains the true difference between the proportion of black drivers and the proportion of white drivers. Alright.